starting. I've done it, Chris.
You've done it, yeah.
Right.
You sure everything's very safe in like, whoop, there we go, look.
This asset is connected. Hi, I'm Peter Haddock, and I'm here inside a construction yard where we're talking about one of my favourite things, folks, battery systems. But this is not just any battery system. This is a Himoinsa one with Chris here. Fantastic to see you here, Chris. And this is a great new product where we're looking at how we can take us to net zero, but how we can be more sustainable and do a bit of peak shaving, folks, so that we can keep the costs down on the grid. Tell me what we've got in front of here and the big news about the capacity.
Yeah, thank you, Peter. So here we have the Himoinsa EHR. It's the 45 kVA, 60 kilowatt hour battery bank.
Yep.
So that's 45 kVA power, 60 kilowatt hours of battery.
Right.
For a layman, let's say you have a kettle.
Yep.
Everybody knows a kettle, 1 kilowatt. If it's a 1 kilowatt load, it'll last you 60 hours before it depletes and needs charging again.
Fantastic.
Okay.
And today we've plugged it into a site cam in as is actually off the grid, and we'll demonstrate that in a minute when we're actually pressing the button to turn this on.
We will.
But next to you, Chris, we've got a whole bank of different things here, different sockets. We're plugged in with this one. Tell me about why we've got all this here.
So first and foremost, you'll see the big red switch, which is we're all about safety.
Yep.
So if for whatever reason we was in an emergency situation, a quick press, that stops
Cuts it
power
off.
instantly.
Yep.
But then we've got all the breakers, circuit breakers here, which govern each of the sockets. So we have two 30 volt single phase sockets.
Yep.
And then we have 400 volts in the 3-phase. And we have the small 16 amp single phase charger for maintenance charge of the lithium batteries, because that's important. We need to keep the lifespan of the batteries, keep them all nice.
Yeah.
And then we have the generator input there, the solar input, and then the trigger for the generator.
Wow, that's a lot of different stuff. But come on, why do I need these big ones? Obviously, that's the input for the generator if you're wanting to twin it up. And this is the important bit about this, folks. This is the brains of a whole on-site grid. So you can have a generator going in there, topping it up. You can also have solar, wind, and other things. And you can sort of trickle charge it overnight, can't you?
Yeah. I think within the power industry, the battery storage system is the enabler. So everybody is talking about the solar, the wind, and we've all have all this excess power. So this will always store all that power ready to deliver to site. So we going to your question, we have different sizes based on the different applications. So we'll go straight to the big one, for example. If we wasn't just powering the offices and we want to actually power this whole site, we would go in on the 63 amp.
Right.
But here the power demand is such that we can use the 32 amp 3-phase socket.
But you're saying to me earlier, when this is pretty cool, folks, imagine this pack here on a job site, but imagine us having to look really high, Chris, because this can power a crane.
It can, certainly can, yeah. So in conjunction with the generator, we can use this to power the crane. Cranes have a big inductive load, you know, it really impacts the genset, so we can absorb that boost with this so that the generator can cope a lot more and it reacts much faster than the diesel genset.
And that optimizes everything, so it gets all the value out of that diesel combination as well. And also you can have a bank of these that actually put together that you can be totally electric in that scenario, can't you?
Yeah.
So that's really important, that peak shaving. That's where, you know, people can actually get bigger bills from the utilities if they don't do that peak shaving.
Absolutely, yeah. And the benefit for the construction site is that where they had such a large genset powering all the time, you place it into peak shaving mode, for example, and you can lower the genset, thus lowering the run times, the fuel, the
cost,
the CO2s, everything. Yeah.
And a smaller genset is also a cheaper option as well, folks.
Of course, yeah.
So this is the control panel.
This is it, yeah. This is the brains of the outfit. So this is a fully developed controller by ourselves in Himoinsa. So we develop this in-house and manufacture it ourselves. So this is the user interface, really simple user interface. You can imagine, Peter, that these units are going on construction sites and sometimes the user of these is not electrically savvy. So we tried to make it very simple, not too many buttons, and literally maybe 4 touches and you've delivered site to power.
So folks, this is the moment that matters. I'm going to press the button and turn this on, turn this site on and all the lights. Here we go. 1, 2, 3, push the button, starting. I've done it, Chris.
You've done it, yeah.
Right. So what happens next?
So what it's doing is it's working out, making sure everything's very safe. In like, there we go, look. So it's happy, the brake has gone on, the lights will be on, and we're delivering site to power. There we go, look.
Fantastic. So
Power
now
to site, rather.
we're looking to see how much load we've got coming through there.
Certainly are, yeah. So we've got a visual here which lets us know absolutely every parameter that we've got going. So currently now we can see here at the bottom, this is the battery indicator.
Yep.
So we've currently got just under 5 kilowatts there. We have a thermostatic load because obviously we've got the heaters on keeping the staff. So that will fluctuate. Above that there is the integration of the solar or the wind or any renewable power source, and then right above there is the genset, so we can see overview of what's being delivered in and what's going out of the batteries.
Yep.
Then if you want, Peter, you can press across.
Ooh, okay, you're trusting me with this.
Yeah, and then the green button.
Then the green button.
And there.
Oh, right.
That would give you if you really wanted to drill down then into what each device is doing, we can drill down into the solar.
Yep.
And what every site manager likes is the daily production. So he can see.
However,
yes.
Right, what I need to understand is what's in here, because this looks cool, and this is something a little bit different that you're going to have to explain to me, because obviously down here, we can't open this at the moment, folks, because we've plugged it in. That's a bus bar?
A bus bar, yeah. So if we want to bring, not just we can bring a grid connection in if the site had a grid connection, but some generators on the larger sets, we connect up individually onto a copper bus bar.
Yeah.
So each phase is on L1, L2 and L3, and it's like a nut and bolt for a layman term.
Right, okay. So that allows us to be really, really clever, and any particular site and any particular scenario, we can do that.
We can, yeah.
So keep it buzzing, folks. That's what that's doing, right? So come on then, let's go around and have a look at what I call the brains inside it. And so come around here with me. So, folks, as we come round here, we're going to open up the two different sections and reveal what's inside. Well, it looks like a lot of clever stuff. The first thing I see as soon as it is smart solar and everything, Chris.
Absolutely.
So we mentioned the solar. The sun is shining here. If we
is.
did have a load of solar panels, what would we be able to do?
So we connect the solar in at the front, and then these are really the brains of the solar. So these are MPPTs, multi-point power tracking, and then what that does is it converts the solar into power and then into the charge of the batteries.
Like, everybody talks to me about things, how does it all work?
Yeah.
There's a big word here called
There
inverter,
is.
right? And people get confused about what that does,
Yeah.
particularly myself.
Yeah.
So explain to me why you need an inverter and what does it actually do?
Okay, so the main source of power is the bank of batteries down here.
Yeah.
So what we need to do is we need to take the power, which is DC here,
Yeah.
out of these batteries.
Yeah.
It goes into this device, which is the inverter, and it converts the DC into AC, which is what we use in our...
This is like the wave. Yeah.
Exactly that, yeah. And then that'll come out there on the output side and deliver it to the sockets that we showed you earlier.
At those different ratings, folks.
It is,
right,
yeah.
okay. What is interesting here, folks, as well, is you'll notice there's not one big battery here, and you've done that for a reason, haven't you? Because
we have, yeah.
It's the longevity of this here, which can last multiple battery lines.
Absolutely.
When you're looking at the whole setup, can't it?
Yeah, yeah. So these, if we look after them, they can last us a lifetime. That's what, you know. But should, on the occasion that we need to, with just 4 simple bolts, the screen, and then it's a cassette that comes out and plug and play, really simple.
And another one in. So, you know, and so when we're looking about how fast battery technology is coming through, you can imagine being able to slot something in here, and it could be a bigger rating in the future, couldn't it?
Of course, yeah, yeah. So, you know, we're future-proofing it. Whatever comes along, we can slot in and away we go. And
I love that future-proof word, folks, because this is why I love talking about electrification, and I love talking about the journey, the hybridization of generators like this, the clever technologies that are in here. And one thing that you need to understand, folks, is this asset is connected.
It is.
Isn't it? And this is the bit here.
Yeah.
And why is that important? Why is the connected bit important?
Because many of these are, let's say, off-grid or in remote locations.
Yeah.
And also on the construction site, the managers they want to know what the power's doing. So we send all this up to the cloud, and then from your smart device or your laptop, we can completely monitor it 24 hours a day, get alerts, text messages, emails, you name it.
Right, okay.
And we're completely round the clock monitoring power to site.
So connecting to a future, which is battery on alternative fuels,
Yep.
wind, solar, means that we can do everything from our seat inside a cabin like
Absolutely.
this, which is exactly what somebody's doing in here, doing some work inside the cabin. So come on, folks, we can prove that this is now a connected work site and connected to the grid that's outside. So here we are. The lights literally are on, aren't they, Chris?
They
Come
are.
through here with me. We can see this is a site cabin, and now it's running off that particular item.
No diesel.
Fantastic.
And it's silent as well, so you could hold a meeting in here and you wouldn't even know what was going on.
So folks, that for me is why this is really important. Chris, you've done such a good job about explaining everything here. Just think about how your site of the future is going to look now, but the site of the future is now, isn't it, Chris?
Absolutely, yeah, 100%.
Great to see you. Cheers.
Thank you, Peter. Take care.